about to say that.
Yeah. Yeah. So now talking about time. People had been measuring time for thousands of years by the daily rising and setting of sun. About 5,000 years ago, when humans settled down to become farmers, time began to matter more than before. Because for farmers, they need to wake up early and they need to go for farming. So they need more, they have to be regular, they have to wake up early. So it was very tough for them for measure the time. So measuring time helped people to regulate their lives. The time interval between one sun rays and the next is a unit of time called day. The time period from one sunset to sun rays is called night. Similarly, the time interval between one new moon and the next is called a month. Whenever the new moon appears, whenever the moon, when it is new, how it will be? How the moon will be when it is new?
I think
You
it's
means
totally circle, ma'am. Full moon light. It's like a full moon, ma'am.
no. New moon means
No,
the
no,
moon is
no.
not visible at all.
Yeah,
New moon
New
means the
moon
moon is
means
not even visible.
there is
Yes,
no
ma'am.
moon. Black moon.
Ah,
Black.
yes.
that's why I stopped recording. I'll stop the share
Okay.
here and I'll share the image for you. Just 1 second. I hope you can see it.
It's loading, ma'am.
Yeah, ma'am.
Yeah, now we
You can
can
see
see
it?
it.
Very
Yeah,
thin.
it's very thin. Why? Because of the rotation of the earth, it appears to be slowly, it appears to be very thin. So it shows, okay,
Yeah, ma'am. I can see like the small border, like the border
yes.
of the
So
moon. I
it
can
Edge
see,
of
ma'am.
shows,
the moon, ma'am.
yes, it shows that 1 month has completed. And a year is measured as the time taken by the earth to complete one revolution of sun. The time has been divided into seconds, minutes, hours, days, weeks, months, years, centuries, millenniums, ages, and eras. So time has been divided into so many things. Yes, can you tell me, Arjun, can you tell me, time has been divided into how many different parts?
Ma'am?
Arjun, can you read out for me?
Okay, ma'am. I bring course book, ma'am.
You don't have the course book.
I have, ma'am.
Read the last 4 lines. Make it fast, Arjun.
Ma'am, I have it all.
Ma'am, page number?
Page number 15. Yes, Arjun. First para, last 4 lines. The time period from one sunset to sunrise is called. Yes, Nitika, you have any doubt? You're raising your hand. Okay. Yes, Arjun.
If Arjun
Make it
will
fast.
not read, I'll read, ma'am. Just saying that.
Same, ma'am.
Yes, Nehita. It's taking a
Ma'am,
lot of time.
ma'am.
Yes,
Yeah.
ma'am. It is divided into 11 types.
Yeah.
Yeah,
And
ma'am.
the sunset to
Seconds,
sunrise is
minutes,
called
hours.
night. Night. It is called
Yeah,
night.
ma'am.
Yes. So it's divided into seconds, minutes,
Yes.
hours,
Hour,
and
minutes,
Hours,
hours,
days,
days,
weeks,
Days,
weeks,
years,
weeks,
months,
months,
centuries, eras.
centuries,
Ha.
millenniums,
And eras.
centuries,
ages, and
millennium,
eras.
yes,
And eras.
and era.
yes,
Oh, I
that's
got it
good.
wrong.
Yes, Sanjana, you're raising your hand. Sanjana, you have any? Yes, Sanjana.
Yeah, ma'am, I have a doubt.
Yeah, what is that?
When new moon arises, then 1 month will complete or next month will start, it says, ma'am.
Yeah, 1 month. It says that 1 month is complete and the next month is starting. Again, when the
Starting or started?
moon starts to appear, it started. The next month has started. It's the arrival of the next month. So as the days passes, the moon will slightly become big. And when at the end of the month, how the moon will appear? It appears
At the
big.
end of the month, it entirely disappears and becomes black color, ma'am.
Yes, it appears big and slowly it appears to be black. So now what happens here? The first devices, what happened now as the time passed? The first devices used for measuring time were in earlier days, what they used to use. Sorry, I'm not sharing the screen for
Handies.
you. Just 1 second.
No.
Yeah, what are these instruments which the ancient people used to use? This is a candle
Sundial.
clock, a sundial, and sorry, I haven't showed you the water clock. Even they used to use water clock. It's there in your course book. A water clock
Yeah,
is
ma'am, it
also
looks
there.
very
Yeah,
strange.
and even you
Ma'am,
have
I
a
think the
big
water clock
sundial
updates
in
very
Jaipur.
fast, ma'am.
Yeah, a big sundial is there in Jaipur, which is called as Jantar Mantar. A water clock or sand clock. Yeah, a water clock is a
Ma'am,
sand.
ma'am, ma'am,
Even they used to use sand clock
ma'am,
also.
Ma'am, what is that?
I have a
Sand.
sand clock, ma'am. I'm 1 second, ma'am. I'm getting my sand clock. I have one.
Okay. Yes,
Ma'am, what you said, ma'am, it is Jantar Mantar or what,
yeah,
ma'am?
it's Jantar Mantar. Yeah, I'll just show the image of that. It's in Jaipur.
Ha, ma'am, we went here, ma'am. In tour also we have gone there.
So this is
Ma'am, we
with
have
the help
seen
of the
this.
shadow,
We have
they
seen
used
I've
to.
this.
seen this, ma'am. Everything this.
Seen this in Jaipur. I had
Yeah.
seen this in the tour.
Yes, ma'am.
In Jaipur, it was there.
Okay.
And ma'am, there was one path. Move your cursor for first one, ma'am. This side. Left.
Left side.
Yes,
Okay.
ma'am. That one also we have seen. That one
Oh,
also we have seen.
okay. So even there's a
We
path
have
over there.
seen this one also, ma'am. Everything we saw, ma'am.
Steps will be there. Until now, I don't
Ma'am,
understand
and
why this
some
path.
round one is also there, ma'am.
Please mute yourselves, children. In daily life, and mostly for scientific purposes, it is important to measure time. A change in time or a time interval accurately. Time is a fundamental quantity. Time is a fundamental quantity. Please underline these two lines. In daily life and mostly for scientific purposes, it is important to measure time. Do not use marker, use pencil, Snitika, because it's a very bad habit. Even you'll continue with the same habit. Okay.
Ma'am. It's highlighter, ma'am.
No, even you must not use a
Ma'am,
highlight.
after sharing the screen, I got just puzzled, ma'am. Where you're telling?
Which one?
Like you're telling something to underline. Where, ma'am?
Yeah, it's in the
Last
third para.
para.
It's in the third para before the picture. In daily life
So
and
in
mostly,
Yeah,
yeah.
between.
ma'am. It's
Okay,
in the
ma'am.
first.
So time is a fundamental quantity. So based on this, we come to know we need the next last para. We need to measure intervals of time which are much shorter than a day. Clocks and watches are the most common time measuring devices used by us. The working of clocks and watches are rather complex. However, all of them use the principle of periodic motion. For measuring time, a motion which repeats itself at regular intervals of time. Even in in the 19s, in 18s, in 1970, in 1980s, so people used to use the clocks which would have the the pendulum. A pendulum.
Ha,
Do you know
ma'am.
a pendulum? You want me to show the image?
Yes, ma'am.
Ma'am,
We
I
know that,
heard
ma'am.
that
Yeah, it is.
when there is no invention of these, any clock, natural clock or candle clock, they used to identify the time by the sun.
Yes. Later on, they try to invent the watches and clocks. So clocks, they used to measure this time with the principle of periodic motion. For measuring time, they used to use a motion which repeats itself in regular interval of time is called periodic motion. What is a periodic motion?
The motion which keeps repeating itself, ma'am.
Yes,
Repeating
at
itself,
regular
At
interval.
a
like
regular
the
At
time.
pendulum
regular
remains
interval
left to
of
right,
time.
left to
Yeah,
right.
I'll
Uniform
just show
motion.
you.
See, ma'am. Yeah, ma'am. We can.
So
Ma'am, in Hyderabad Museum, one clock will be na, ma'am.
yes, a clock will be there. So here, there's a pendulum over here, so it will be moving periodically.
You keep moving like this, ma'am.
Yes. So this periodic motion is a repeated one. So it will repeat itself, isn't it? At regular intervals of time, it will repeat itself. So the clock will be moving and the pendulum will be moving itself. So it's called as a periodic motion. A motion which repeats itself at regular intervals of time is called periodic motion. So here is one of the most common and most uh, these devices they used to use in 90s, in 1980 and 1970. Now I don't think you all have such type of clocks at your home. Do you have? No. So they used to be there in early days. So these clocks, these devices, they show periodic motion, which is the simple pendulum. They follow simple pendulum. They follow the procedure of simple pendulum. So now we'll discuss about the simple pendulum, how it works. Just one second, I'll share the slide with you. So here we'll discuss about the simple pendulum, how it works. A simple pendulum consists of a small metal ball called the bob. Here you can see a bob over here. I'll just show it to you. Here you can see a bob. Here you can see a metal bob. So this
Yes,
bob
ma'am.
is suspended by a long thread over here. So it's been suspended by a long thread from a rigid support. So this is the rigid support which the ball is being attached here. So why it's been attached to a rigid rod, it is attached such that the bob will move freely. It will swing back and forth. It can show back and forth movement. It can move freely. So because it is attached to a rigid support, the bob is attached with a long thread. It is attached to a rigid support. In order to uh, allow this ball to move freely, to and fro motion. What it will show? It will show a to and fro motion. So this back and forth motion of a simple pendulum is called as oscillatory motion. This back and forth motion is called as oscillatory motion. Please
Ma'am,
underline
it's
it.
like this.
Yes. Please underline it. What it is called? What the back and forth motion of a simple pendulum called as?
Oscillatory motion.
Oscillatory motion. Yes, good.
Ma'am, I think we learned this last year, ma'am.
Yeah, you've learned it.
Oscillatory motion.
You even have learned about different types of motions also. What were they?
Yes, ma'am. We learned it, ma'am.
Ma'am, I learned
The types of motion we
rectilinear
learned.
motion,
Hmm.
periodic motion,
Yes.
Periodic motion
also
or oscillatory motion?
Yes.
rectilinear also.
The vibration also we sense some motion is that is also called oscillatory motion only.
Yeah.
Yeah, ma'am. Keep going
Vibratory
back and
motion.
forth.
Yeah. Turning fork.
Yes,
Example
ma'am.
for that is turning fork. Okay. And even the
And
chair, rocking
there
chair.
were some motion like
Yeah, ma'am.
curvilinear motion,
Yes.
circulatory motion,
Rectilinear motion, curvilinear motion.
translatory
Circulatory also, ma'am.
motion,
Yes.
Circulatory motion.
rectilinear motion,
Circulatory,
Straight,
ma'am.
straight motion, ma'am.
Straight one is
Straight
called
and free fall, I
translatory
think.
motion,
Yes.
translatory motion.
translative.
Straight one, ma'am. Straight motion is called rectilinear
Yeah,
motion,
ma'am.
ma'am.
Or translatory
Translatory
motion.
motion,
Yes.
Yeah.
rotational motion also there.
Yes,
So
ma'am.
last year you've learned about so many types of motions, and now
And ma'am, in
you're
periodic,
going.
non-periodic is also there, ma'am.
Yes, non-periodic is
Also
also.
linear motion, ma'am. Linear.
Linear is rectilinear only, na. Linear means straight
Ah,
line.
yes, ma'am. It's straight only.
Yeah, so I think you remember so many things. So that's great that you haven't forgotten anything. So now
That
we'll
was the
discuss
easy
about
topic.
the oscillatory motion, which is shown by a simple pendulum. So the motion of a pendulum was first studied by Galileo. So it was first
Yeah, ma'am.
studied
We
by,
got this in our social book last year,
It is
ma'am.
Galileo
Galileo.
Galilei.
Yes,
yes.
ma'am.
Galileo Galilei.
Galileo
I
Galilei.
remember his name.
It was there in our social book, ma'am, last
Yes.
term.
So just give me a minute.
It is said to be in motion. Cars, buses, trains, aeroplanes, etc. are the objects that first come to our mind when we talk about motion. However, yet another object has motion. Try to recall a big grandfather clock. Do you remember seeing at the bottom of the clock a long stick with a ball attached? That is a pendulum. It moves back and forth in harmony with the tick-tocks of the second hand. In this lesson, we discuss the simple pendulum, or simply the pendulum. Objectives. At the end of this lesson, you'll be able to describe a simple pendulum, define oscillatory motion and time period of a simple pendulum, differentiate between uniform and non-uniform motion, plot distance time graph. Have you ever observed a wall clock? A simple wall clock or a wristwatch has a circular dial with 3 needles. The circular dial is divided into 12 equal parts, with each division representing 5 minutes. Observe the dial more closely and you will find that it has 60 smaller divisions in it. A single small division represents 1 minute. The longest needle, which moves the fastest, is known as the second hand. It completes 1 revolution in 1 minute. The smallest needle, which is also the slowest, is called the hour hand. It completes 1 revolution in 12 hours. The needle smaller than the second hand and longer than the hour hand is the minute hand. It moves slower than the second hand but faster than the hour hand. It completes 1 revolution in 1 hour. A simple pendulum consists of a small metallic ball suspended by a thread. The metallic ball is called the bob of the pendulum. The thread by which a bob is suspended is loose at the lower end and is fastened at the top to a stand. When the pendulum is not moving, it is said to be at rest. This position of rest is also known as the mean position or the equilibrium position of the pendulum. Students, let's quickly check what you have learned. Select the correct option and drag it into respective box. Suppose the bob of a simple pendulum is in equilibrium. If we now take it to one side, left or right, and release it, it begins to move to and fro. This to and fro motion of a simple pendulum is called the oscillatory motion. One full to and fro motion of the pendulum is called an oscillation. The pendulum completes 1 oscillation when its bob, starting from its equilibrium position O, moves to one extreme position A, from there to the other extreme position B, and then back to O. Alternatively, an oscillation can also be measured as the movement of the bob of a pendulum from one extreme position A to the other extreme position B and back to A. The time taken by the pendulum to complete one oscillation is called its time period. You can compute it with the help of this simple exercise. Take a simple pendulum. Let it come to rest. Identify the equilibrium position O on the ground below. Now take the bob to one extreme position A and identify it on the ground below. Start a stopwatch and release the bob at the same time. When the bob comes back to the extreme position A, note the time on the stopwatch. Repeat the activity. This time, start from the equilibrium position O. Note the time taken by the pendulum to complete the one complete oscillation from O to A to B, B to O. The time so recorded is the time period of simple pendulum. Motion can be classified as uniform or non-uniform depending on the speed of an object. If the speed of an object moving along a straight line keeps changing, its motion is said to be non-uniform. A bus, for example, moves at varying speeds over varying stretches on its long route. Hence, its motion is non-uniform. If an object moves along a straight line at a constant speed, then it is said to be in uniform motion. A car, for example, may maintain the same speed when it covers a short distance. Motion of objects can be presented in pictorial form with the help of distance-time graph. For this purpose, first draw a horizontal line to represent the x-axis and a vertical line to represent the y-axis and mark them as OX and OY. Measure time along the x-axis and distance along the y-axis. Mark values for the time and the distance on the respective axes. Now plot the points on the graph paper, each pointer presenting a specific combination of distance and time values. Join all the points on the graph to get a linear distance-time graph, which shows that the vehicle is moving at a constant speed. From this graph, we can calculate the distance covered by vehicle at a particular moment. We can calculate the time at a particular distance from the starting point. In the same way, we can calculate speed also. Fill in the blanks with the correct answers. Summary. Taken by simple pendulum to complete one oscillation is called time period of simple pendulum. If an object moves along a straight line at a constant speed, its motion is said to be uniform. If an object moves along a straight line at a speed that keeps changing, its motion is said to be non-uniform. Motion of objects can be presented in pictorial form by their distance-time graph. The distance-time graph for the motion of an object moving with constant speed is a straight line.